Hello, welcome to yet another episode of Chintasaala, a blended learning platform. Through this series, we're going to cover the topics of physics, grade 12, CBSE, based on NCERT. Please take a notebook and a pen and note down these notes as the video is prepared in the form of capsule module notebook. This video will be followed by another set of videos where we discuss conceptual questions with answers and numerical problems with solutions. So let's begin. Here we discuss about electric charge, conductors and insulators, basic properties of electric charge, unit of charge, Coulomb's law in vector form of the unit electrostatics. Let's begin. Electrostatics, the branch of physics which deals with charges at rest. This is very important. The charges at rest. The branch of physics which deals with the charges at rest is called electrostatics. Electric charge. When a body has deficiency or excess of electrons, from the normal due share, it is said to be electrified or charged. There are two kinds of electrification. As we know, like charges repel, unlike charges attract. The property which differentiates two kinds of charges is called polarity of charges. So polarity of charges is the property by which it differentiates the two kinds of charges. Conductors and insulators. Substances which allow electricity to pass through them easily are called conductors. How can they pass electricity easily? Because they have electric charges. That means they have electrons that are comparatively free to move inside the material. For example, human bodies, animals, metals, earth, etc. Now, on the other hand, substances which offer very high resistance to the passage of electricity, that means they don't allow the electricity to pass through it. They are called as insulators. Substances which offer high resistance to the passage of electricity through them are called insulators. Example, glass, porcelain, plastic, nylon, dry wood, etc. In between, there are another type of material. They are called semiconductors, which we will learn it in the later part of the course, which offer resistance to the movement of charges, which is intermediate between the conductors and insulators. So, conductors which allow electricity to pass through them easily. Insulators offer very high resistance. Semiconductors are in between conductors and insulators. Basic properties of electric charges. As we know, there are two types of charges, positive and negative. The first property is very simple, additivity of charge. If a system contains n charges, q1, q2, q3, etc., qn, then the total charge of the system is the sum of all charges, that is total charge q is equal to q1 plus q2 plus q3 plus q4, etc. up to qn. Let us have a little comparison between charge and mass. Both are scalar quantities. Mass of a body is always positive, it is increasing, but charge can be negative or positive. depending upon the nature of the charges. Therefore, proper signs have to be used while adding charges in a system, especially in numerical problems. Second property is charge is conserved. That is, the total charge of the isolated system is always conserved, or another way, law of conservation of charge, charge can neither be created nor destroyed. Third property is very important, very simple. The total charge is always an integral multiple of E. That is a integral multiple of E, the basic unit of charge. That is the charge on an electron or a proton. Or mathematically we can say total charge is an integral multiple of basic unit of charge. Q is equal to Ne, where N is an integer, positive or negative. So that's all about the basic properties of charges. The three important basic properties are additivity of charge, total charge is equal to Q1 plus Q2 plus Q3 etc. Q, and second one is charge is conserved. Total charge can neither be created nor destroyed, or total charge remains constant. And the quantization of charge is the third property. The electric charge is always an integral multiple of the basic unit of charge, that is E. The unit SI unit of charge is Coulomb and is denoted by C. 1 Coulomb is the charge flowing through a wire in 1 second if the current is 1 ampere. This is from the formula I is equal to Q by T. 1 Coulomb of charge is equal to the charge on 6.25 into 10 raised to 18 electrons. So what is the charge on 1 electron? That is nothing but 1 divided by 1 divided by 6.25 into 10 raised to 18 Coulomb. That is nothing but 1.6021 into 10 raised to minus 19 coulombs. If a body contains N1 electrons and N2 protons, electrons means negative charge, proton means positive charge. The total amount of charge on the body is given by C is equal to N2E, positive charge, plus N1 into minus E. That is, total charge is equal to N2 minus N1 into E. Since N1 and N2 are integers, their difference is also an integer. Hence, the total charge on any body is an integral multiple of E, quantization of charge. Smaller units are microcoulomb, 10 raised to minus 6 coulomb, and millicoulomb, 10 raised to minus 3 coulombs. So what is the SI unit of charge? Coulomb, and it is denoted by C. What is the charge on 1 electron? 1.6 into 10 raised to minus 19 coulomb. Next, we are going to discuss about an important topic of this session, Coulomb's law. According to this law, the electrostatic force between 2-point charges is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. So what is the statement? What does the law state? Electrostatic force between 2-point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. This force can be attractive or repulsive depending upon the charges are like or unlike charges. The force always acts along the line joining the centers of the two charges. Now let us find out a mathematical derivation for this. Consider 2-point charges Q1 and Q2 held at r distance apart in vacuum. According to Coulomb's law, the magnitude of the electrostatic force between the charges is given by F is directly proportional to Q1, Q2. That is, the force is directly proportional to the product of their charges. F is inversely proportional to square of the distance between them. Mathematically, we can write F is directly proportional to 1 by r square. Combining these two, what you will get it? F is proportional to Q1 Q2 divided by r square. Adding a proportionality sign, we can remove the proportionality. Adding a proportionality constant, we can remove the proportionality sign. So F is equal to a constant K Q1 Q2 divided by r square, where K is a constant whose magnitude depends upon the system of units employed and the nature of medium in which the charges are placed. So in SI unit, when the charges are placed in vacuum, in SI unit and the charges are placed in vacuum, K is equal to 1 by 4 pi epsilon 0. What is the value of K? 1 by 4 pi epsilon 0. This is nothing but putting the value of epsilon 0 absolute permittivity, we get the value of K is equal to 9 into 10 raised to 9, where K is the absolute permittivity of free space, which is equal to 8.854 into 10 raised to minus 12 C square n raised to minus 1 m raised to minus 2. Hence, electrostatic force between 2 point charges F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by r square is equal to, substituting the value of K, 9 into 10 raised to 9 Q1 Q2 divided by r square. A point to be noted, Coulomb's law is applicable only to point charges. If Q1, Q2, the product of charges is greater than 0, the force is positive and repulsive, and if Q1, Q2 is less than 0, the force is negative and the product is negative and the force is attractive. I'll repeat, if the product Q1, Q2 is greater than 0, the force is repulsive. If the product Q1, Q2 less than 0, the force is attractive. Since force is a vector quantity, let us see Coulomb's law in vector form. Here F21 is a force acting on Q2 due to Q1, and F12, the vector F12 is the force on Q1 due to Q2. Similarly, the unit vector pointing from Q1 to Q2 is R12, and unit vector pointing Q2 to Q1 is R21. According to Coulomb's law, electrostatic force F21, that is on Q2 due to Q1, is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R square R12, and F12 is 1 by 4 pi epsilon 0 Q1 Q2 divided by R square R21. F12 is acting alone R21 and F21 is acting alone R12. We know the unit vector R12 is opposite to the unit vector R21, and hence F12 is equal to minus F21. Now let us find the definition of 1 Coulomb. In the formula, F is equal to K Q1 Q2 divided by R square. Put Q1 is equal to Q2 is equal to 1 Coulomb. R is equal to 1 meter. F we get 9 into 10 raised to 9 newtons. So 1 Coulomb is the charge that when placed at a distance of 1 meter from another charge of the same magnitude in vacuum experiences an electrostatic force of repulsion of magnitude 9 into 10 raised to 9 Newton. Force between multiple charges. Force on any charge due to a number of other charges is the vector sum of all the forces on that charge due to other charges taken one at a time. The individual forces are unaffected due to the presence of other charges. This is what is termed as principle of superposition or superposition principle. So the principle of superposition says that in a system of charges Q1, Q2, Q3, etc. Qn, the force on Q1 due to Q2 is the same as Coulomb's law, that is, it is unaffected by the presence of other charges Q3, Q4, etc. up to Qn. In mathematically, vector sum of the forces F12, F13, F1n can be expressed as F1 is equal to F12 plus F13 plus F14 plus etc. up to F1n. F1 is equal to Q1 by 4 pi epsilon 0 sigma I is equal to 1 2 to n Q1 divided by R1I the whole square R1I cap. So if you put the value for I 2 to n, you will get these forces. The vector sum is obtained as usual by parallelogram law of vector addition. So that's all about this part of electrostatics. So we'll be continuing with further topics in the continuing videos. Do keep watching. Enjoy learning. Thank you for watching Chintasaala, a blended learning platform.